So we will, I have collected some questions from week 1 and week 2. Okay, so what we'll do first, quickly we will go through the concepts of week 1 and week 2, and then we will try to solve those questions. Okay, so everyone please be ready with the pen and paper. First thing. Second thing, so this is not any open session, so we'll not go through, with deep, I mean, with deep discussion, or let's say any derivation and all, because this is just a revision of the concepts. Anyway, so let me share my screen. Okay, can you see this white page is visible to all of you?
Yes, sir.
Yes,
Okay,
it
all
is
right.
visible.
Yeah. So we will start with the very first thing, which is called joint probability mass function. Okay, so I will write joint PMF, and then we will move on what is called marginal PMF. Okay, and then the next concept we will quickly see what is the conditional PMF, and then we will move on the concepts of independent random variables. All right, and then there is something called IID. So what is the full form of IID? It's independent and
Identical.
Identically.
correct, identically distributed.
Distribution.
Okay, great. So then the final topic is from week 2, which is called function of random variables. Okay. So what do you mean by function of random variables? Suppose you have two random variables. So what might be another functions? You can define, let's say, z1 as a function, let's say x plus y. You can define z2 as, let's say, x into y. You can define z3 as maximum of x comma y, and you can define z4 as a minimum of x comma y. So these are some standard functions of random variables. So anyway, let's start. So we will see what is the joint PMF. So in stats 1 course, you have already seen what is the meaning of PMF, right? That is called probability mass function, right? So probability mass function. What do you mean by probability mass function? I mean, what it tells us? Anyone? Anybody? What it will give you? What do you mean by? Suppose I'm saying I have a random variable x, and for this random variable x, I have probability mass function. So what does that mean?
So the probability covered within a given range.
Okay. So yeah, anybody else?
So probability at any point.
So basically, correct. So what it tells, it's so this PMF will give you the information about probabilistic behavior actually. Probabilistic behavior for each values of this random variable x. Okay, so what is the meaning of probabilistic behavior means suppose my random variable x is taking value x1, what is the probability for that? If it is taking x2, then what is the chance it will take x2? So it will give you the idea of probabilistic behavior. So there were two main property for being a valid probability mass function in case of single random variable. What were those? First one, all the probabilities should be greater or equal to 0. And second property was summation of all the probabilities should be equal to 1. Yes or no?
Yes, sir.
Yes,
So
sir.
this information was for single random variable. Now, what if you have two random variable? So that's then this joint probability mass function comes into the picture basically. So what is the joint mass PMF? Suppose you have two random variable x and random variable y. So here, what is the x1, x2, xn? These are the range of x, right? So in case of two random variable, let's say for random variable x, there is a range. I'm denoting it as a tx in general. For y, suppose range is ty. So how will you define the joint PMF? So basically, Here we are writing probability x equal to x. Since we are dealing with joint PMF, so the notation is fxy t1 comma t2 is equal to probability x equal to t1 and y equal to t2. So this means x is taking value t1 and y is taking value t2. So this t1 is from one of the value is from tx and t2 is one of the value from t1. Okay, so this means t1 belongs to t of x and small t2 belongs to t of y. So this is just to write the joint probability. So basically this means what is the probability that you are saying x is taking value, let's say 1, and y is taking value 2, something like that. Okay, now so what is the key properties actually again? So what were the key properties in case of single random variable? All the probabilities should be greater or equal to 0, or else you can say it should be between 0 and 1, correct? And summation of all the probabilities should be equal to 1. Now in case of two random variables, first property will be this all fxy small x comma small y should be between 0 and 1. So this capital X capital Y represents the random variable, small x small y represents the one of the instances, basically you can say one of the values. Second property is summation. So since we are dealing with two random variables, so we will be adding throughout the range of x and throughout the range of y. It will be fxy x comma y. I mean sum of all the joint probabilities should be equal to 1. Okay, is this clear? Hello. Yes, no?
Yes, sir.
Yes,
Yes,
sir.
sir. It's clear.
Yes, sir.
Okay, so there is, I will take one example. So whenever you have two random variables, right? So there will be possible combinations, right? For both random variables. So what you can do, you can make a table of those random variables. Let's say I'm just making some random example. Suppose this is random variable x and random variable y. So my random variable x is taking value, let's say 0, 1, and 2, and random variable y is taking value 0 and 1. Now you can see there are lots of possibility, right? X and x can take value 0, y can take 0, x can take 1, y can take 1, x can take 2, y can take 1, x can take 2, and y can take 0. So you can see lots of possibilities are there. So just suppose, so this is 1 by 6, and let's say 1 by 6. This is 1 by 8, and this is, let's say, 1 by 4, 1 by 8. Not wrong, so it should be 1 by 6. Now can you check, tell me whether this is joint PMF or not? Is this valid or not? So what should be your first property? All the entries should be between 0 and 1. Yes or no?
Yeah.
Yes,
Yes.
sir.
Yes.
And addition of all the values is equal to 1 here,
1. Yeah, it should be 1.
Yes,
right?
sir.
So that means this is valid. So sometimes people actually don't know how to read the table. So what if I will ask, what is the probability x equal to 1 and y equal to 1? What is the value?
1 by 8.
1 by 8.
Right. So x equal to 1 is this, y is equal to 1 is this. So what is the corresponding probabilities? This is this part, right? Which is 1 by 8. Correct? Very good. So this is the valid joint PMF table because all these values are, I mean, these two properties is fulfilled. Okay, well, so the next concept is called, okay, so what, which way you like? I mean, suppose I discuss this question, so you want something question related to this right now, or should we quickly finish the concept and then we will solve the questions from all over the topics?
We'll finish the concept and then we'll get into the problem, sir, if that is
Oh,
okay.
all right. So does this sound good to everyone? Okay, like we'll quickly go through. Yeah, all right.
Yes.
Yeah.
I have a doubt.
Yeah, go ahead, please.
Here x and y here x and y are the random variables
Yes.
of two different, they can be random variables of two different events,
Yeah, can be.
independent events.
It can be independent event, right? Suppose let's say very
Like-
simple standard example. Suppose x is something, you are rolling a die and you are noting down the output, and y is I'm rolling a die and I'm noting the output. So it will be 1 to 6 for you also, and for me, a random variable y will be 1 to 6.
What I mean to say is X can be a rolling of a dice and Y can be picking up cards from the deck. It
Yeah,
can be
yeah.
like
Even
that
you
also.
can say y is throwing a coin or something like that. That's possible. That's not a problem.
Okay, sir. Okay.
Okay, well, so next thing is called marginal PMF. So marginal PMF means basically you have been given the joint probability mass function. So marginal is, PMF means what is the basically PMF of a single random variable. I mean, if you have joint PMF, then what is the PMF of X? What is the individual PMF of Y? So that is called marginal PMF. So how you can deal with, okay, for example, here, if I will ask what is the probability x equal to 0, then what you will do? Probability x
We
equal
will.
to 0.
1 by 6 plus 1 by
So
4.
basically, this means I'm interested in this column, right? Yes or no? I'm saying
Yes,
what
sir.
is the probability x equal to 0? So
Yes.
x equal to 0 means it may be 1 by 6 or 1 by 4. Correct? This means what we are doing? We are adding
Correct.
for the possible values of y, right? For the range of another random variable. Yes or no? What if I will ask what is the
Yes.
probability
Yeah.
y equal to 1? So y equal to 1 means what? Basically, it may
1 by
be
4 plus 1 by
1.
1
8
by 8 plus 1 by
correct.
1 by 8
I'm
plus
talking
1.
about this row, correct? So this means here what you are
Correct.
doing, you are adding all the joint probability for the possible values of x, correct? So that's what we have to do in case of
Yeah.
marginal PMF. So suppose x and y, these two are discrete random variables. So there is some background noise. Can you please mute? Yeah. So yeah, whenever you have doubt, you can unmute. That's not problem. Okay. So suppose this joint PMF is given to us. So this is joint PMF is given to us. Okay. So what is the marginal PMF? So means what is the probability mass function of random variable x? So I told you if you need probability mass function for x, what I have to do? I have to add the joint PMF for the, if you need for x, you have to add for the all the possible values of y. Yes or no? Means basically you have to sum over those for those that random variable which you don't want. Okay. Now what is fy of y? See, I need y, right? So I have to sum over the all the possible values of x. Understood?
Yes, sir.
Okay. So whenever you have been given this joint PMF table, right? So marginal is very straightforward. So this will give you the fx of x, and this will give you the fy of y. So if you will add this row, right? If you'll add this row, what it will give you? So total, what will be the total? Okay, let me make the table here so that it should be clear again. So suppose this is x, this is y, 0, 1, 2, 0, 1. So 1 by 6, 1 by 6, 1 by 8, and it was 1 by 4, 1 by 8, and 1 by 6. Now, so whenever you need marginal PMFs, right? So you can add columns and you can add rows that will give you the marginal PMF. So if we, okay, for example, if I need fx of 0, so what does this mean? This means probability x equal to 0. And when this probability x equal to 0, it will be when x is 0 and y is 0, or probability x equal to 0 and y equal to 1. Correct or not? So basically what you have to do, you have to add 1 by 6 plus 1 by 4. Am I right?
Yes, sir.
Okay.
Yes, sir.
What if I will ask fy of 0? So fy of 0 means this first row, right? I have to add these things. So this means probability y equal to 0. So when is probability y equal to 0? Just try to understand this event. So when probability y is 0 means when x is 0 and y is 0, or x is 1 and y equal to 0, or x is 2 and y equal to 0. Basically, if you will add here, you will get fy of 0, and if you add values here, it will give you fy of 1. And here, fx of 0, and this second column, fx of 1, and third column will give you the fx of 2. So basically, this is the valid PMF of a single random variable. Okay, so far so good.
Yes, sir.
Okay, great. So the next thing is, let's try to understand the conditional. So in terms of events, if you see, let's try to understand the conditional part. So in terms of events, suppose you have two events, A and B. Suppose these are two events. Okay, how will you write probability A given B? This is probability A intersection
Intersection
B
B
and divide by
divided by
probability of B.
B.
Or else can I say probability event A and B and divide by probability of B, right? So what is this? This is now let's talk about in terms of random variables. So just consider, let's say I'm saying uh, uh, probability y given x equal to x. So basically what I'm trying to say, I need okay, before this let's try to write like this. Suppose I'm saying f y given x equal to x at y. So what does this mean? This means I'm saying, so this is given that x is equal to x, what is the probability y is taking value small y?
Why?
Okay, now so this is you can treat as a and this is you can treat as a b. So what else can I write? Can I write probability y equal to y and x equal to x? So there is replacement of, and you can replace with comma and divide by probability of x equal to x. Any doubt?
No, sir.
No, sir.
And what is the numerator part? Numerator part can I write fxy, x comma y in general. And the
Yes, sir.
denominator
Yes,
part,
sir.
what can I write? Fx of x. So you
Yes,
can
sir.
see
Yes,
it.
sir.
What is this? Basically, I can write fy given x equal to x at y is nothing but fxy x comma y divided by fx of x. Let's change the order. Suppose I will say fx given y equal to y at x. Then in the numerator part, there will be joint probability again, and denominator part this given part, right? So given is the marginal PMF of random variable y. So what is this? This is, you can say this is joint PMF and divide by marginal. Yes or no? And this is conditional. So if any of these two quantities given to you, let's say conditional and joint is given to you, can you calculate the marginal?
Yes, sir.
Yes.
Right? So that's the one of the important things. So basically, from here you can write joint PMF is equal to conditional times marginal. So actually, why this relationship is very, very important. So we are not going to discuss in the depth, but I will give you the idea. So what happens in sometimes real situations? Suppose you have you might have, I mean, you will get data such that in that scenario, it's very difficult to model the joint probabilities directly. So what you can easily model, you can easily do, you can easily deal with the marginal, you can easily deal with the conditional. And suppose you need some joint probabilities. So using this concept, conditional into marginal, you can actually compute the joint PMF. Anyway, so that's not key. So uh, let me discuss one major concept that is, then I will move on the other concepts. I think something, some raise. Yes, yes. Any doubt?
Uh, Hi. So I had a question. Unless the probabilities are independent, we'll need this formula, right, to calculate the joint PMF.
Correct, correct.
Otherwise, they
So,
in a question. Sorry.
Yeah, go ahead, go ahead, go ahead.
Yeah. Otherwise, you need to be given a table where the joint PMF is already given to you. Otherwise, it's going to be difficult to calculate the joint PMF, right? Unless either you have to be given the joint PMF or you need to know the conditional PMF.
Conditional
Sorry,
PMF.
the
Yes.
conditional probability.
Conditional probability. Actually, in real life, not always. I will not say always, but in most of the situation, it's difficult to deal with this joint probabilities, right? Then what we'll do, we deal with the conditional and margin. Right? See, if your random variables are independent, right? So anyway, conditional is going to be same as marginal, right? So that will be clear in a minute. What I'm saying, conditional is equal to marginal. Okay, so as of now it's clear.
Sure.
Yeah. So what I'm trying to say, so this joint PMF, basically I can write fxy, x comma y. This is, can I write conditional? So fy given x equal to x into y, right? Into fx of x. Are you getting what I'm writing here?
Yes, yes, it
Okay.
is clear.
So what if you have more than two random variables, right? Okay. Rather than first of all, before this, can I write? Let's change this. What if, can I say fx given y equal to y at x into fy given fy of y, right? I can write both way, right? Would you agree with me?
Yes, sir.
Okay. Now, what if you have two random variables? Sorry, more than two random variables. So suppose fx, y, z, and let's say x comma y comma z. Let's say you can start with marginal. So let's say I'm starting with marginal fx of x. So you can something to keep in your mind. So you can say y, suppose marginal is given to you. That means you are already done with this random variable, right? So that can come under the given part, right? So if x is given, so can I write y given x equal to x at y? Yes, no? And later, finally, can I write z given that y equal to
Why?
y, x comma x, and add z.
Yes, sir.
Would you
Yes,
agree
sir.
with me?
Yes, sir.
Yes.
Yes, sir.
Yeah. So yeah, so this is about joint PMF, conditional and marginal. Actually, there was one question, I think so, when I was in. Okay, well, anyway, so answer is visible, but let's try to understand. So question is, Kunal and Sanskriti are playing a game. So Kunal will roll a fair six-sided die and Sanskriti will flip a coin as many times as the number shown on the die. So you can see here in this scenario, conditional is very easy to model. Correct? Why? Okay, first of all, let's try to understand question. What x is, x represent the number displayed on the die and y represent the number of heads obtained by the Sanskriti. So if x equal to 5, okay, before this, what is the x? X represents the, so first of all, I roll a die, suppose I got 4, okay? Yes or no?
Yes,
Just
sir.
try to understand. So this
Yes, sir.
means x is 4. Now, after getting 4, what is the next task? Sanskriti will flip a coin as many times. Basically,
Four
Sanskriti has to
times.
flip a coin 4 times, right? So let's say y represents the number of heads. So this whole conditional part will not follow binomial, because at the end we what we are doing, we are going to toss a coin 4 times, right? And each time Sanskriti may get head or tail, head or tail, head or tail. So basically she may get 0, 1, 2, 3, 4. That's the maximum possibility.
Sir, can you repeat? Sir?
See, if 4 times, suppose you roll a die, you got 4, that means Sanskriti has to flip a coin 4 times, right? Okay, if you understand this random variable, what this random variable says, you got 4 here, 4 number 4, and you have to roll a coin, toss a coin 4 times, right? So if I'm interested in number of heads, so how many heads I can get? I may get 0 head, 1 get head, 2, 3, and 4. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
And for each trial, suppose first trial, let's say for the first trial, Sanskriti may get head or tail. Then the second trial also. Then the third trial also. For the fourth trial also. Are you getting my point? So
Yes,
Yes.
sir.
each trial is Bernoulli. So if you will add these 4, it will be binomial or not, right? Yes or no? It will be binomial. Are you getting my point? Binomial, what is the parameter? See, if I'm saying x follows binomial n comma p, So what does this mean? X can take any value 0, 1, 2 up to n, and P is the success probability, right? So it will be binomial. Okay, what is the maximum value? Suppose you got 4, so it will be 4, comma, and since coin is fair, so success probability will be half. Is this clear?
Yes, sir.
Right? So here in the
Yes.
question it was given x equal to 5, so it will be x equal to 5. Why not first option is correct? Why the second? What's the wrong with first?
You can only get 5 heads if you
5
toss
heads.
the coin.
And I can get
I
0 head also, right?
yes, sir.
Okay.
Yes.
Okay. Is the situation and solution clear?
Yes, sir.
Okay.
Yes.
So if everyone has pen and paper, so can you solve this and let me know whether you are getting this 0.16 as the same correct answer or
Sir, can you show the question?
okay, question. Okay, all right. So let me write here itself. So you have to calculate probability y equal to 1 given that x equal to 5. Done.
The 5 by 32?
What is the value of 5 by 32? 0.16.
0.15625.
Yeah, I mean it's close 0.16.
Yeah.
Okay, so basically, what was your approach? So we know y given x equal to 5 is binomial 5 comma half, correct? It is asking what is the probability that y equal to 1 given that x equal to 5. So the whole random variable is binomial. So what will be your approach? Now what should I write? 5?
1.
Yes, that's the PMF of binomial. And then half raised power
Uh,
5 basically.
1.
Yeah,
Yeah.
half raised power 1 and 1 minus 1 by 2 raised power 4. So basically again,
Yeah.
it will be 5, 7 and into half. Yeah, correct. So that should be correct. Okay, anyway, so let's start with the concept.
So if I can just ask one question. So if the question was not a binomial, but what is the probability of getting a heads, then we should be calculating the expected value, right?
No, it should be mentioned the expected value. So till week 2, there is no expectation. Okay. So if it's saying what is the probability of y equal to something, then you have to deal with conditional into marginal. Sorry. Then joint also you need, right? So before that, you need to calculate joint and then marginal. So basically, if it is asking, see, y equal to something. So you know what is the y, right? Understood? So there will be information about joint also in this case. Okay. Then you can calculate the margin.
Okay.
Yeah. So the next concept is function of, sorry, before function, we need to discuss the independence part. So let me quickly go through that. So everyone is okay with this, right? I mean, are you able to follow me?
Yes,
Yes, sir.
sir.
Okay, great. So I will start with the events which we have discussed in Stats 1 course, but so that you can relate. But anyway, so suppose you have two events, let's say A and B. These two are events. Okay, if these two are in events. So first of all, when you will say A and B are independent, so what do you mean by independence actually? Means what is
The
the meaning
outcome
of?
of one event doesn't affect the outcome of
Oh
other.
yeah, correct. Happening or non-happening of the one event doesn't affect the happening of the another event. Very good. So I mean there is no dependency basically. So if I will talk about in terms of notation, so can I write probability that A given B? I mean whether B is happening or B is not happening. It should be probability of A,
Yes, sir.
or else can I write probability that probability of happening B whether A has already occurred, probability of B whether A didn't occur. If this is equal to probability of B, I will say A and B are independent because there is no dependency. Would you agree with me?
Yes, sir.
Now, if you see the conditional probability formula, so conditional probability formula is probability of A given B. So this is nothing but probability of A intersection B divided by probability of B. Yes or no? So from here, can I write probability of A and B is equal to probability of A given B into probability of B? Now, if A and B are independent, so this probability of A intersect A given B, can I write probability of A?
Yes, sir.
So I can write probability of A into probability of B. So this is the formula which is we use to test the independence of two events. Now, if I will talk about in terms of random variable, so independence of two random variables. So I'm writing RV for random variables. This is not any standard sort, but I'm just using for convenience. Suppose x and y are two discrete random variable. Okay, then this is independence of so if fxy x comma y is equal to fx of x into fy of y, then can I say for all x belongs to range of x and y belongs to range of y, then can I say x and y are independent, yes or no? By using this information, so you can see this joint probability is equal to product of their marginals, yes or no?
Yes, sir.
So basically you
Could you
can
repeat the last part? This function you wrote.
I can write like this: probability x equal to x, probability x equal to x, and this is I can write probability y of y. So what is happening here? So this is joint probability, right? Joint PMF. So joint probability is equal to this is marginal PMF of random variable x, and this is marginal PMF of random variable y. Yes or no? So if the joint PMF is equal to product of their marginal PMFs, I will say two random variables are independent. Yes or no?
Yes, sir.
Yes.
One
Yes, sir.
thing here, this conditional probability A given B is equal to probability of A. I will say A and B are independent, right? Or vice versa also. Probability of B given A is equal to probability of B. I will say A and B are independent. So in terms of random variables, you can say this conditional PMF is same as marginal. Then I will say these two are independent. So you can use this one or the next one. So basically what you can check, fxy, y given, I mean fx given y is equal to y at x, this would be equal to what? Tell me, fx of x or fy of y?
F F F of
Fix.
X of
F of x,
X.
right? Because happening or non-happening of another random variable shouldn't affect the happening of the one random variable, right? Okay. So what is the y given x? So this means x already happened. So this shouldn't affect the happening of the one random variable. Okay. So you can go with either approach. That's not a problem. Okay. All right. So far so good. So the next thing is called IID. So this means independent. There should be concept of independent and identically distributed. So what do you mean by identically distributed?
All the marginals are same.
Yeah. So basically they should be from the same population distribution. Okay. So what I mean by same population distribution, let me take very simple example. You will give me the answer. Suppose you are doing any analysis and let's say you are interested in to know the amount of time a plant, I mean leaf of a rose plant. Okay. Uh, I mean how much amount of time it takes. Something like that. So you have collected two samples. Suppose sample one, you have collected data from let's say lotus plant and let's say lily plant and some rose plant and some other. And the second sample, you collected the data from rose plant one, and there is another rose plant and there is another rose plant and so on, and all are independent. I mean there is no dependency in this. Which sample you will prefer and why?
I'll do sample number 2 because our assessment is on the rose plant only, right?
Rose plant only, right? So basically the population distribution is same, right? I mean this will give you the more good result, right, as compared to the first one. Yes or no? If you are collecting the data based on same characteristics, but if it is from the same distribution, same population, then that will give you the good result. Is the rough idea clear? So what I mean to say here, suppose you have some random variables x1, x2, so that is the meaning of identical. I mean this data, let's say this is x1, this is x2, this is xc, all are from the same distribution actually. Suppose these are the random variables. All right. Then they said to be, I will write, they said to be, IID, this is short form for if, first one, if they are independent. Okay. And the second one, what is the second property? The marginal PMFs, basically they are marginal PMFs. So what is the, let's say for each xi, I will write fx of xi. These marginal PMFs are identical, means all are same. So basically the marginal PMF of random variable x1 is same as marginal PMF of x2, then which is same as x3 or xn. So that's
do they all have to be uniform? Like all of them have to be 1 by n, or
no,
can they
no.
be different?
Shouldn't be 1 by n. The marginal PMF is same, means PMF can be anything. PMF can be, it can follow binomial, mean all xi. So what is the meaning of, see, if I will say x1 is from binomial with some parameter, x2 is also from, so let's say this is 5 comma half, 5 comma half basically, okay. You have collected one data, one x1 from this, one x2 from this, one x3 from this, okay. So this is identical, right? All are from same population distribution. Okay, that doesn't means the thing which you are saying my random variable is taking some value, let's say x1, x2, x3, and happening of all the values is same, right? So that's not a case here. Okay, it should be from the same distribution. It can be binomial, it can be Poisson, it can be discrete uniform, it can be any exponential or something like that. Okay. So
Okay,
that is
okay.
the meaning of same distribution. Okay.
So
If it's from
binomial
the,
will be uniform, right?
no, what do you mean by first of all saying binomial is uniform? Are
No, I
you
mean
trying to
when
say
you
all exercises from?
yes, yes,
Yeah,
all the
yeah,
instances will produce same probability.
same, yeah.
Okay.
So basically, what you mean is the meaning of IID. So suppose I'm saying x1, x2, so on, xn. This all are IID. Let's say very simple example. Bernoulli 1/3. Okay. So what is the meaning of this Bernoulli 1/3? So this means x1 is also from Bernoulli 1/3, right? And x2 is also from Bernoulli 1/3. So these are, and anyway, these are independent as well as identical. So identical means this random variable is from Bernoulli 1/3. This random variable is from Bernoulli 1/3. I'm not saying x1 is from some distribution and x2 is from something else some different distribution. Okay, is this clear?
Yes, sir.
Okay, let me take one simple example. I'm not going to mention any different distribution. So let's say x is there, y is there, and possible values of x is 0 and 1. Possible values of y is 0 and 1. So this is suppose 1 by 4, 1 by 4, 1 by 4, and 1 by 4. So first of all, check whether x and y are IID or not. So what you will do? You will check all the joint probability is equal to product of their marginal. Yes or no?
Yes, sir.
To check
But
the
that
IID
you're
part,
checking
right?
for independence, right?
Okay,
So
okay. One second. In IID itself, independent and identically distributed. Okay. So what I'm saying, suppose I have given this table to you and I ask whether you have to check whether x and y are. Okay, first of all, let's check whether x and y are independent or not. What you will do? Joint probability equal to product of their marginal. That's what you have to do.
yes,
Yes, sir.
What is the marginal of f? Okay, what is the fy 0?
half
This will be half. This will be half.
all.
This will be half.
Yeah.
Okay, grand total is 1. So let's check the joint probability. So let's check fxy 0 comma 0, it should be equal to fx of 0 into fy of 0, right? Then I will say basically I have to check all the possibility. What is the fy fx 0? It's 1 by 4, sorry, 1 by 2,
Half. Yeah.
right? Fx 0 is 1 by 2, fy 0 is also 1 by 2, which is nothing but 1 by 4, which is equal to this joint probability. Similarly, what about fxy 0 comma 1? This means this should be equal to fx of 0 into fy of 1. Everyone is getting the way I'm writing this and this.
Yes,
You have
Yes,
to
sir.
sir.
check this
You are
inequality.
multiplying those
Yes, sir.
marginals to get the
Marginal.
joint, right?
So this fx0 is 1 by 2. Fy of 1 is again 1 by 2, which is 1 by 4. This is same as this part. Actually, if you see fxy, 1 comma 0, this will be same as fx of 1 into fy of 0, which is half into half, which is again 1 by 4. So you can see the joint is equal to product of their marginals, right? Then fxy 1 comma 1, fx of 1 into fy of 1. Again, you can see, would you agree with me? Now, using this property, can I say x and y are independent? Yes or no?
Yes.
Yes,
Now,
sir.
if x and y are
Yes.
independent, what is the second property of checking identical? Their marginal PMFs are identical or same. So you can see what is the marginal PMF of x? It's a 0 and 1. And what is the probabilities? It's taking 1 by
Half
2,
and
1
half.
by 2. This is marginal PMF of x. What is marginal PMF of y? Same. Oh, sorry, 1 by 2 and 1 by 2. Yes or no? Is this marginal PMF same?
Yes, sir.
Yes, sir. But in the case of see, let's say you were saying if you do binomial, if you're going to do
Hmm.
binomial, they may not be the same, right? Like 0 could be I don't know,
No,
half,
why
and
not?
1 could be 3/4.
Whatever. See, you okay? Don't go with this. Okay, okay. See, the thing is, where you got confused. So actually, in case of binomial, right? So if I'm saying, let's say x is from binomial, let's say 5 comma half. Okay, y is also binomial 5 comma half. Okay, if I will
Yeah.
write what is the probability x equal to 0, again it will be same, right? 5 c 0, half raised power 5. Yes or no?
Yes.
Why?
Yes.
Understood? So probability is anyways, probability is going to be same. Why? Because this original PMF is same, original distribution is same from where we are drawing. Okay,
Okay. Okay.
right? Now it's clear, right? So basically, it should be from the same distribution, same population. See, if you see this Roach plant, so here what is the population distribution? All are identical or not? Identical means all are from the Roach plant itself, right?
Yeah.
And
But
here
the
this is not
probability
identical.
in binomial would still be different, right? Because each one will have 5C1, 5C2, 5C3. I mean, that
See,
would be the
1 second. Okay, 1 second. See, what is if I will write x 0, 1, 2, let's make it 2 only, just for simplicity. Okay, to avoid the things. So this is 2. Okay, tell me what you will write for probability x equal to 0. I think you are
1/4.
not, whatever. So basically I will write 2c0 half raised power 2, correct?
Yeah.
2c1 half raised power 2, 2c2 half raised power 2, correct?
Yes.
What if I will write for y 0, 1 and 2? What is the probabilities for y? Again same, 2c0 half raised power 2, 2c1 half raised power 2, 2c2 half raised power 2. What is? You will get the same values, right? Why? Because these two are the same. These two are the identical. Correct?
Yes. Yes. Yes.
Okay.
So that's what you mean by distribution, right? I mean, that's
Yeah, that's what I mean by the distribution. X is from x and y
Okay.
is from the same distribution.
Okay. Okay. Thank you, sir.
Oh, yeah. So the next concept is called function of random variables. So I will go through the some examples. I will try to solve, and then maybe that will give you the idea. Okay. So as I told you in the beginning, so function of the random variable means it may be x plus y. You can say mod x plus 7y or x into y or xy by 2, anything, any function of two random variables. So maximum and minimum of two random variables. So okay, so let's start with the very simple part of this question. So suppose I'm saying I'm just taking x and y are independent. Okay, suppose I'm saying x and y are independent, and x is from binomial, let's say 3 comma 1 by 3, and y is from Bernoulli, let's say 1 by 4. Now you see, can you say these two are IID?
No,
No,
sir.
sir.
No, right? I'm dealing with just a independent random variables. Okay. Now suppose this is the situation, and I'm defining a random variable z1, let's say x plus y, and my question is you have to find the PMF of y. Sorry, PMF of z1. So okay, to know the PMF of z1, you should know the range of or possible values z1 can take and the corresponding probabilities. Yes or no?
Yes, sir.
Yes, sir.
Okay. So I will give you the idea here. So okay, if x is binomial, okay, if x is binomial 3 comma 1 by 3, so tell me what is the possible values first of all x can take?
0, 1, 2, 3.
0, 1, 2, 3, right?
Yes.
Now if 0, 1, 2, 3, what is the probability mass functions will be here? Okay, that I will write later. If y follows Bernoulli 1 by 4, so what is the possible values y can take?
0 and 1.
0,
0
1.
and 1. Very good. Now, whenever you are dealing with some function of random variable y, so see, sometimes you can do calculation very quickly. That's not a problem. That's a very good thing. But what I would suggest you, I mean, if you are in exam and all, so write down all the possible values of x and y, because in that case, see, if you are not making a table, sometimes, I'm not saying it's always, sometimes due to exam pressure and time constraint, so you may miss some cases, and because of that your question will be wrong. So what's a good way? I mean, it may take, I mean, you may feel it's okay, some laborious work, but that will give you the correct answer. So what I mean to say actually, so what is the possible values of x and y here? Basically, if you see, so x is x can take 0, 1, 2, and 3, right? Y is 0 and 1. Basically, can I write 0, 0, 0 and 1? Correct?
Yes, sir.
Then 1, 0, 1, 1, 2, 0, 2, 1, and the last possible case is 3, 0 and 3, 1. Okay. Now, what is the function? Function is x plus y. So, what is the addition of here? 0, 1, 1, 2, 2, 3, 3, 4. So what, see here why I told you to make a table, because suppose I ask what is the probability z equal to 1, right? So sometimes you may write this one and you forget this case, right? Then your answer is wrong. Okay. Anyway, so now is this clear?
Yes, sir.
So one more
Yes.
thing, actually before this, actually you need all this, what is the PMF for X? Basically what I mean, suppose I'm saying X is 0, 1, 2, 3. So you have to calculate what is the probability at X equal to 0. So basically it will be, X is binomial 3 comma 1 by 3. So it will be 3C0, 1 by 3 rest power 3, right? So 3C0, what is, am I doing correct? What is the value for this? Can you calculate? Not 1 by 3, no, not 1 by 3. So 3C0, 1 by 3 raised power 0, 2 by 3 raised power 3, correct? So this is 27, and this is 2 to
8 by
8,
7.
8 by 27, right?
Yes, sir.
Yes or no?
Yes, sir.
And for 3C3, it will be 3C3, and it will be 1 by 27. Can you calculate one more values and then we can move on? Yeah, anyone?
Two by nine.
2 by 9, right?
Yes, sir.
Okay. For 2, I think, correct? And it will be then, if then it will be 4 by 9. Okay, well, so what is the y? Y for y is Bernoulli, I took 1 by 4. So 1 by 4 is the success probability, right?
Yes, sir.
X and Y are independent. Yes, no, I given the question, right? Are you getting? I'm able. Can you hear me?
Actually, sir,
Yes,
your
sir.
voice is breaking.
Yes, sir.
Now am I audible?
Yes, sir.
Hello. Yeah, yeah.
You're audible.
Okay, great. Yeah. Okay, great. Thanks. So, okay, what you have to do? We have to calculate probability X equal to 0 into probability Y equal to 0. So, what we have to do? 8 by 27 into 3 by 4. Yes or no? And then 8 by 27
Again, we lost you.
correct? Yes or no? Now am I audible? Hello.
You are audible, sir.
Okay. Yeah.
But I
So
want to understand.
is this?
Sorry. I just want to understand how you just multiplied it, right? That is only possible if they are independent, right?
Yeah, yeah, yeah.
Okay.
So it will see this kind of information will be given in the question whether those two are independent or not. If it's not independent, then some other probabilities will be given to you so that you can deal with the questions. Okay, so don't worry about those those part of the question. Okay, so let me take very simple. I mean the one of the which is like most of the time it's famous question. So let's say I'm saying maximum of x comma y. Okay, so what is the maximum of y? So what is the x and y, possible values of x and y? So it was 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, and then 2, 1, 3, 0, 3, 1. Now, if according to your function z equal to maximum of x comma y, right? What is the maximum of 0 comma 0?
0,
Maximum of 0 comma 1?
1,
1,
1, 1. Maximum 2 comma
2,
0 is 2, 2, 3, and 3, right? Now, what is the probability? Let's say z3 is equal to small z3. So suppose this is z3. Now, what is the probability that z3 will take value 0? And when this is true? So this is true when x is 0 and y is equal to 0. Yes or no? I mean, 0 is only possibility. So basically, I can write this as a first of all 8 by 27 into that was 3 by 4. Understood?
yes, sir.
Right? And when z is, it will take value 1. So when x is 0, so that is 0 is 8 by 27 and y is equal to 1 is 1 by 4. Are you getting from where I'm writing these probabilities? I'm writing this probability from here. Okay. Now,
yes,
the
yes.
next thing is x is 1 and y is 0. So what is the probability x is 1? It's 4 by 9. And what is the y is 0? 3 by 4. So this will be 4 by 9 into 3 by 4. X is 1 and y is 1. So 4 by 9 into 1 by 4. And this is x is 2. So what is the probability x is 2? 2 by 9. And what is the y 0? It's a 3 by 4. And then here 2 by 9 into y is equal to 1. It's 1 by 4. And what is the y x equal to 3? It's 1 by 27 into y is 0. So which is 3 by 4. And then 1 by 27 into 1 by 4. So actually what I mean, what I'm trying to say here. So what is the PMF of Z if you want to calculate? So what is the PMF of Z? What is the possible value Z can take? Tell me.
0, 1, 2, 3.
0, 1, 2, and 3. Very good. Now let's calculate the probabilities for Z equal to Z. What is the probability Z equal to take 0? There is only one case. Let's say this is A1. Just assume. I'm not going to calculate the final value. So this will be A1.
So by Z you mean Z3, right?
Yeah, sorry. Yeah, Z3 actually. Okay, A1. Now what is the probability that Z equal to take value 1? There are 3 cases, right? Yes or no? These
Yes.
are the 3 possible values. So this will be, let's say, I'm writing B1, B2, B3. So this will be B1 plus B2 plus B3. Would you agree with me?
Yes.
Let me use some other color. Let's say blue itself. For 2, there is 2 cases, right? Let's say C1 and C2. So for 2, it will be C1 plus C2. And for 3, so it's a, let's say, D1 or D2. So D1 plus D2. So now this is something basically you can do directly. So suppose I ask what is the probability that Z equal to 1. So now what you have to think when Z is equal to 1. So suppose you have made the table for all the possible. So within a minute, you will write these 3 cases, right? Without any mistake. And if you are writing directly, so sometimes you will write, okay, so probability x equal to 0 and y equal to 1 and probability x equal to 1 and y equal to 0 and done. I mean, sometimes it may happen, it may not. I'm not discouraging you if you're doing directly, if you're saving your time, but to reduce the chances of making mistake, I'm just telling you this idea. Is the idea clear?
Yes, sir.
Yes.
Okay. So I will take one important thing which you should do because sometimes that is important, and then I will move on the questions part. Okay. So what is that important part actually? I mean, if the maximum of two random variables is given to you, minimum is given to you, then something you have to keep in your mind. Suppose I'm saying x1 and x2 is IID x. Okay, miss x is something. X can be here binomial, x can be here Bernoulli or anything, right? Suppose I have defined z equal to maximum of x1 comma x2. Now the question is, what is the probability z greater than small z? So whenever you have been given any question, right, related to maximum, so it's good to convert the greater than sign in less or equal to if the maximum is given to you. Why? I will tell you the reason. Okay, 1 minute. I will tell you the reason why. First of all, can I write this as a 1 minus probability z is less or equal to small z?
Yes, sir.
Right? So since z is what? Okay, why this is important actually? So first of all, suppose I'm saying 2 comma 3 is less or equal to 3. Can I say?
Yes, sir.
Yes, sir.
Right? Yes or no? If this is the case, can I say 2 is less or equal to 3 and 3 is less or equal to 3?
Yes, sir.
Yes.
See, I'm saying maximum of 2 comma 3 actually I mean here. Now if you have converted this you are dealing with the maximum question and you converted to less or equal to sign actually, so can I write this probability z is less or equal to z? So this is nothing but this is maximum of x1 comma x2 less or equal to small z. Now if this is the case, by using this concept, can I write probability x1 is less or equal to z and x2 is less or equal to z? Would you agree with me?
Yes, sir.
Since these two are independent, so can I write probability x1 is less or equal to z into probability x2 is less or equal to z? Yes or no?
Yes, sir.
If that is the case, since both are IID, so both probabilities will be same. So at the end, I can write probability x1 is less or equal to z whole square, because this will be the same, this will be the same, right? Because both are IID. Yes or no?
Yes, sir.
So finally here what it will be 1 minus probability x1 is less or equal to z whole square. Okay, so this is something you can keep in your mind. If the maximum given is given to you, try to convert into less than or equal to sign. If minimum is given to you, try to convert into greater than or equal to sign. Let me take for the minimum one also. So suppose I'm taking z1 is defined as minimum of x comma y. So suppose something you have been asked, z1 is less or equal to some z. So okay, then what you have to do, convert into the greater or equal to sign if the minimum is given to you. Why? Again, so what is the minimum of 2 comma 3? Can I write this is greater or equal to 2 comma 2 if minimum of, they can I write 2 is greater or equal to 2 and 3 is greater or equal to 2?
Yes.
Yes,
Right?
sir.
That's the key idea actually. So if you want to calculate probability z1 is greater or equal to z, let's say this one. So I can write probability minimum of x comma y is greater or equal to z, and then uh, let's say x1 and x2, since we are dealing with x1 and x2. So I can write probability x1 is greater or equal to z and x2 is greater or equal to z. Since these two are independent, I can write probability x1 is greater or equal to z into probability x2 is greater or equal to z. Now since these two are IID, I can write probability x is greater or equal to z whole square, and finally you can substitute the value here and you will get the answer for this. Is the idea clear?
Yes, sir.
Okay, let me take one numerical example. Okay, suppose for example I'm saying uh, what to say, yeah, let's say x1 x2, this is IID binomial, just let's for simplicity let's say binomial 3 comma half. Now I'm saying z is defined as maximum of x1 comma x2. You have to calculate probability z less or equal to 1. So since this is maximum problem and you have been asked less or equal to 1, so it's things are in favor with us, right? that means it's already in less or equal to sign. So can I write maximum of x1 comma x2 is less or equal to 1, right? And then since maximum is less or equal to 1, can I write x1 is less or equal to 1 and x2 is less or equal to 1? Yes or no? What should be my next step?
Probability of x lesser than equal to 1 times probability of x2
Yeah, why
lesser
I
than
can
equal
write?
to
Because these two are independent, because
independent.
of independent concept. Since these two are IID also, I mean, see, if you will calculate probability x1 is less or equal to 1 from binomial, this and this both will give you the same answer, correct? So at the end, this will be same as probability x is less or equal to 1 into probability x is less or equal to 1. So basically, at the end, I can write probability x is less or equal to 1 whole square. So basically, how you will calculate probability x is less or equal to 1? Basically, it will be probability x equal to 0 plus probability x equal to 1 and whole square. So you have to calculate this value. So how will you calculate probability x equal to 0? So this is 3c0 1 by 2 raised power 3 plus 3c1 1 by 2 raised power 3. Calculate, add and take square. That will be the final answer. Is the idea clear? Yes, no? How to deal with maximum minimum function?
Yes, sir.
Okay, so everyone is ready with pen and paper. So I'm going to give you the question related to this maximum and minimum, and then. Okay, are you ready with pen and paper?
Yes, sir.
Okay, all right, great. So, okay, there it went. Let me check. Okay, all right, great. So this is the question. Okay, anyway, answer is visible. Let me. So this is the question. You have to calculate probability z is less or equal to 3. Okay, so I given some 3 to 4 minutes. Let me know when you are done with this. Okay, if you in between, if you feel if you don't want to try, you can let me know. Okay, but I would encourage you to try so that these are the questions actually which has been asked already. You know, some of previous terms. Okay.
So 1 by 4 is the answer? Yes.
Okay, let's see. We will solve. So I got one vote for 1 by 4. Anybody else? So only one people is trying. What about others? Okay, are you trying? If you're not trying, let me know so that I can't. I shouldn't wait, right?
Sir, we are trying this one.
Okay, okay, great. Yeah. All right. Thanks. Okay, so one more thing. Are you writing all the 36 outcomes? Okay, 1 by 4.
1 by
Votes.
4. Found it.
Okay, so some lots of votes I got. Okay, so should I start?
Yes.
Okay, so if x1 represent number of obtained in the first throw, so what is the possible values x1 can take?
1 to 6.
1
1
to
to
6. Very good. What about x2? Again 1 to 6, right? Now see here it's also mentioned independently. So these x1 and x2 are independent. So question is z is defined as maximum of x1 comma x2. You have to calculate the probability of z is less or equal to 3. So basically, so this means what? Probability maximum of output of x1 and x2, this should be less or equal to 3, right? So there is two approach actually. So one approach is you can think of the cases. So first of all, what are the possible cases when maximum is less or equal to 3? So it may be 1 1 1. Maximum of these two is less or equal to 3, right? It may be 1 2, 1 3. Yes or no? I can't write 1 comma 4, right? Because maximum of 1 comma 4 is not less or equal to 3. Next, can I say 2 1?
Yes, sir.
Then tell me the next cases.
2 2.
2 2
2
2
2,
3
2
2
3.
3.
up to 3 3.
No.
3 1.
Can I write 2 4?
No, sir.
No, right? Because maximum of
3
2 comma 4 is 4, but 4 is not less or equal to 3. So next is 3 comma
1.
1,
3 2.
3
3 2
2.
and 3 3.
3 3.
That's all, right? These 9 cases, right? So these 9 cases is out of what? Out of 36. This is the favorable. If you go with the very basic probability approach, so favorable case divided by total case. What is the favorable case when a maximum of x1 x2 is less or equal to 3? Those are 9 and total is 36. So 9 by 36, which is 1 by 4. Would you agree with me?
Yes, sir.
Now let's go with the standard approach which I told you. So see, this happens here, so it's fortunate for us. So what is the second approach, the usual one? How will you start? Probability z is less or equal to 3. This means probability maximum of x1 comma x2 is less or equal to 3. So this means, tell me next step. I have to write x1 is less or
Less
equal
than
to
equal
3
to
and
3.
x2 is less or equal to 3. Now
Yes.
probability x1 is less or equal to 3 into probability x2 is less or equal to 3. Now let's make it equation star, because we don't know what is the x1 probability of x1 is less or equal to 3. How will you calculate? So probability x1 is less or equal to 3. This means what? X1 can take value 1 plus probability x2 can take 1. Sorry, x1 can take 2 plus probability x1 can take 3. Yes or no?
Yes.
Yes.
What is the probability x1 will take value 1?
1 by
1 by
6.
6.
1 by 6, because this is just outcome of rolling a die. Again 1 by 6, 1 by 6, 1 by 6, which is 3 by 6, which is 1 by 2. So this is 1 by 2 into same probability x2 is less or equal to 3. This is again it will be 1 by 2. So 1 by 2 into 1 by 2, which is 1 by 4. So both way you can find the same answer. Okay, is the question clear?
Yes, sir.
Okay, so the next part is okay, there is another part. There it went. Yeah. Anyway, answer is, but let me hide somehow. But anyway, so tell me what is the value of A?
Nine. Oh, sorry.
Oh.
No, no, no.
just think it. Take your time. See, 2 marks. That means 2 into 2.5. So that is 5 marks out of 100, right? So you lose 5 marks. So please take some time.
8. Is that correct?
Okay. See, I don't know. I will solve it in front of you.
Okay.
The 7.
Okay, 7, 8, 9. Three answers I got. Anybody else? Okay, so please try also. Don't worry, I am going to give you any penalty. This is not exam, but if you solve, you will get some idea. Okay, I'm able to do this kind of questions in the time limit or something like that. Okay, you'll gain some confidence. So please try to solve it.
Is it
Yes.
16?
Yes.
6.
16?
6, 1, 6. Okay.
2.
2. Okay. Should I do? Or anybody is trying? Okay, so correct answer is 7. Let's try to see how. So let's try to understand. So it says probability that Z is equal to 4 is A by 36. We have to find the value of A. What is the Z? So Z is nothing but it says probability that maximum of x1 comma x2 is 4. Correct? Yes or no? So you have to think all those cases when maximum of x1 and x2 is exactly equal to 4. So that means what are those cases? It can be 1, 4.
1, 4,
Yes or
2,
no?
4,
2, 4, 3, 4, 4, 4.
and 4, 1, 2, 1.
4, 1, 4, 2.
Correct. 4, 1, 4, 2, and 4, 3.
Yes.
Right? These are the cases when maximum of these two is equal to 4. Yes or no? How many cases are? Okay, if I will ask what is the probability for this case, what you will say? The probability that
7 by 36.
right. So this is 7 cases, 7 favorable cases out of 36. So what is the value of A? It's a
7.
7. Is the clear? Panda clear?
Yes, sir.
Huh? Okay. So let's try to solve the question something related to okay, it's end. I have some question done first. Yeah, can you solve it? And it's a function of random variables, and you have to find the PMF of Z. I mean, basically, you have to find all the possible values of Z. And I told you what should be your good approach. So 5 minutes will be more than enough for this question.
B.
Okay, I got one vote for B. Let's wait for others.
A.
Okay. Why A? Because it's a uniform, right? See, don't worry. Whatever the way you have approached, you can tell me. So I will tell you whether it's wrong or right. Okay. So that okay. So are you trying or should I wait few minutes?
So can you show the question once again?
Hmm, hmm.
Option B, sir.
Okay. One more vote for option number B. Okay, so I will wait for one more minute and then I will move on. Or if you are trying, let me know. I will wait.
Option B, sir.
Option B. Okay.
Option B.
Option B. Okay. So I think if most of the people are with option B. I think that should be correct. Let's see. Yeah. So option B is correct. Let's try to solve it. Okay. So X and Y are IAD uniform -1. So basically X and Y both are uniform, right? So this is a discrete uniform. This is taking -1, 0, and 1. What is the Z? Z is okay. Z is defined as absolute value of X plus Y. So what is this meaning? So X, that means what? X is taking value -1, 0, and 1. What is the probability associated with each value? This is 1 by 3, 1 by 3, and 1 by 3. Same for Y also. Yes or no? Correct? Now, what should be my next step? My next step should be I should write all the possible values, which may take some time, but it will give it correct. So, what are the possible values? It will be -1, -1, -1. So, just fix one value of X and change for all Y. 0, -1, and 1. Then 0, -1, 0, 0, 0, and 1, and then 1, -1, 1, 0, and 1, and 1. So what is the Z equal to mod of X plus Y? This will be 2. Yes or no?
Yes, sir.
And then 1, then 2, 0,
0.
0.
then 1,
My
0,
1.
1, 0, 1, and 2. Very good. Now, what is the probabilities associated with each value? So what is the value for 2? What will the probabilities? Basically, fz of z. Tell me. So, what is the minus? What is probability x will take -1 and y will take -1? Since these two are independent, so it will be
So 1
1
by
by
3
3
is
into
1 by
1
3.
by 3, which is
1 by
1 by
3.
9, right?
Yes, sir.
So basically, 1 by 9 will be for all cases, right? You can see if you take any value, it's the 1 by 3 into 1 by 3, 1 by 3 into 1 by 3. Yes or no?
Yes.
So this is 1 by 9, 1 by 9, 1 by 9, 1 by 9, and 1 by 9. Very good. Now, what is the possible value Z will take? Since I'm
0,
going to
1,
deal
2.
0, 1, 2. Very good. So 0, 1, and 2. Now, if I have to write the probabilities. So what is the probability Z will take 0? In how many
1 by
cases Z
3.
is taking?
1 by like 3 by 9.
Yeah, 1 case,
That is 1 by
2
3.
case, 3 case. This will be 1 by 9 plus 1 by 9 plus 1 by 9, which is 3 by 9. So this will be 3 by 9, basically 1 by 3.
1 by 3.
What about Z is equal to 1? So 1 is taking 1 case, 2
4 by
case,
9.
3 case, 4 case. Very good. This will be 4 by 9. And what about 2? So 2 is
2 by 9.
1 case
2 by 9.
and 2 case. So 2 by 9. So this is the correct PMF of Z. That's all. You will get 3 into 2.5. I mean, 3 marks. Later it will be converted to 100. That's the another thing. But you'll get the marks. Okay, understood? Is this clear? Idea clear? Function of random variable? Yes, no?
Yes.
Yes, sir.
So there is one more question. So answer is 0.5, but you have to tell me, you have to find x equal to 0 given that z equal to 1. I'm writing here. Probability x equal to 0 given that z equal to 1. You have to calculate this value. Okay. I am giving some 2 minutes for this question. Calculate and let me know. So table is in front of you so that you can easily find out the values.
Two by 9.
2 by 9, right? Okay. Let's
2
see.
by 9.
2 by 9. Okay.
Yes, sir. 2 by 9.
Okay. 2 by 9.
Half.
Half. So actually 2 by 9.
0.5.
Yeah, half is 0.5. Okay.
1 by 2.
1 by 2. Okay. So 2 by 9
1 by
is
2.
not. Sorry?
1 by 2.
Yeah, 1 by 2. Okay. 1 by 2. I got some more votes for 1 by 2.
0.5.
So 1 by 2.
Yeah, see, if you are saying 1 by 2.5, both are same, right? Doesn't matter. But let's go with this. So 0.5 or
Yes, sir.
1 by
1 by
2. Okay. Okay. Shall I solve this then? See, 2 by 9, you are saying, so 2 by 9 means simply you are saying z equal to
joint.
2 or something. Right? Yeah, that's what. So that is something you have to keep in your mind actually. So let's try to understand. So this is saying probability x equal to 0 and z equal to 1. So probability x equal to 0 given z equal to 1 is what? What is can I write? Probability x equal to 0 and z equal to 1 divided by probability of z equal to 1. Yes or no? As per the definition. So far so good?
Yes, sir.
Yes.
Yeah.
Right.
Yeah.
So
In
now,
that case, it should be 1 by 2.
yeah, probability z equal to 1 is something what we can, it's 1 by 3 from here. Sorry, not z 1 by 3. It's 4 by 9. But what we have to think here, okay, so this probability x equal to 0, this z is what? Mod of x plus y equal to 1. Can I write?
Yes.
Yes.
Okay. So basically what I'm trying to say, see what is the internal thing? X equal to 0 and z equal to 1. So this is true when x equal to 0 and z equal to 1. Basically x is 0 and z is 1. When this is true? This is true only when x is 0 and y is minus 1, x is 0 and y is 1. These are the two cases when z is 1. See, z is 1 in other cases also, but what is the condition? X equal to 0 and z equal to 1. Z should be 1. Understood? So we have to add these two cases. So basically it will be probability x equal to 0 and y is equal to minus 1 plus probability x equal to 0 and y is equal to 1 divided by probability z equal to 1. So basically this will be 1 by 9 plus 1 by 9, which is 2 by 9 divided by what is the z equal to 1? This is 4 by 9. So this will be 2 by 4, which is nothing but 1 by 2, which is 0.5. So this is the correct answer. Is the idea clear?
Yes, sir.
Yes, sir.
Okay. Yeah.
Sir, do you mind me asking, like, how did you find the probability of z is equal to 2 is equal to 1 by 9? Like, I missed that concept.
Z equal to 2.
These probabilities, how did we achieve these probabilities?
This one?
Yes, yes.
Okay, so actually, if you see what is the possible values, I took all the possible combinations of x and y, right?
Yeah, that
So
I
far, this
understand.
is okay. Okay, so what is the possible value? Z can take 0, 1, and 2.
Yeah.
Correct?
Yes, yes.
Now, in what cases Z is taking value 0? So there are three cases, right? If you see this red one, which I highlighted with red one. So
Yes,
this
yes.
red possibility when Z is 0, so 1 by 9 or 1 by 9 or 1 by 9, so 3 by 9. And then when Z is will take value 1, so you can see there are 4 cases. So for each cases probability is 1 by 9, 1 by 9, 1 by 9, 1 by 9. Similarly for the 2, which is I have highlighted with the yellow part. Now is this fine?
So it is like we have achieved a mod of x plus y is 9 cases. So these each are the one of the case. So it is 1 by 9.
You can think like that also, or else you can think x and y are independent. So what is the probability for x is 1 by 3 into 1 by 3, so 1 by 9. You can go with that also.
Okay. So
Okay. So
when like we should not mix up this with the marginal PMF, right?
no, it's not a marginal. It's a PMF of function of two random variable. So
Two random.
marginal is one when I'm dealing with only single
One
variable.
of
So
the variable.
basically one of the variable. Yes.
Okay. Okay, sir.
Okay. So this question. Okay. What about this question? Can you solve this, everybody? Hey, by the way, if you are getting bored, let me know. I will stop the session. Okay.
This is fine, sir.
Means
Please.
if you feel I'm giving too much questions, too many questions to solve you. So sometimes people don't like to solve questions. So that's what. I think this is simple concept you can use. Actually, this is not from week 1 and 2, but I just gave to solve you to just to check whether you are able to solve it or not. I think it's from week 1 and 2. So yeah, because expectation and variance we are dealing in week 3. But anyway, I think you can solve it, right? I don't think there should be any problem.
Sir, see,
See, okay, let's see. I have to solve it actually. Are you sure it's a C? Or you just simply C8, C2 and
yeah, it's just scribbled it, sir.
okay, no problem. That's all.
A.
A, okay.
Yes, sir. A is right, 100%.
Okay, should I start?
Sure.
Okay, yeah. So basically, if you see x follows binomial n comma p, so what is the information? What are the information given to us? First of all, I can write, okay, this yellow color is okay. Oh, okay. So expected value of x is n into p. Everyone is okay? And what is
Yeah.
the variance of x? It's n p into 1 minus p, right?
Yes, sir.
So this np is given to us as a 2, and np into 1 minus p is given as a 3 by 2, correct? Because expected value is 2 and variance is 3 by 2. So from where can I substitute the value of np? 2 into 1 minus p, it's a 3 by 2, correct? From where I can get 1 minus p as a 3 by 4. So what is the value of p? P is 1 by 4, right? So we got value of p. We need a value of n also. So if you substitute here, so what is the value of n here? It's a
8.
8,
Yes, sir.
correct? Now, so x equal to 2. So basically it should be 8c2, yes or no? ncx
Yeah.
and p raised power x and 1 minus p, which is 3 by 4 raised power 6, right? Am I right?
Mhm.
So basically you have to solve this. If you solve this, you will get the correct answer is A, okay? So I'm just skipping it because it's just a basic mathematics, okay? So you have to factor this, I mean, you have to convert in 8 factorial to divide by 2 factorial into 6 factorial. Okay, should I solve? Because I want to discuss some other questions. Is this okay? Can I move?
Yes, sir. Yeah, that's
Okay.
fine.
Yes,
Yeah.
sir.
So let me deal with this. Okay, what about this question? Again, function of random variable. Let's try to solve this. Or should I discuss directly? What do you want? You want to try?
Yes, sir.
Okay, if you want to try, then fair enough. Uh, Try for 2 to 3 minutes and then I will move it.
Done, sir.
Done. Got the correct answer, 0.33.
Yes, sir. 0.33.
Yeah, let's wait for 1 more minute, then I will start the solution.
Done, sir.
Done. Okay.
Yes,
Getting
sir.
the same answer?
Yes, sir.
0.33.
Okay. All right. So what is the questions? What question says? So x1 denotes the number on the ball drawn from arm 1. So that means it's x can take value 0, 1, and 2. First of all, what is the probabilities? If it's just three ball,
1/3.
1/3,
1/3.
1/3, 1/3.
Very good. See here in the one question we solved, it was clearly mentioned uniform. Right here you have to identify. Same for x2, 1/3, 1/3, 1/3. All right, great. So what we again I told you, right? What is the good approach to start? So basically, I mean, see, to avoid the confusion, you can write with the all the possible combinations. So it's a 0, 1. Just fix one value here, and let's say 1, 1, 2, 1. Correct? Then 0, 1, 2, 2, 2, 2, 0, 1, 2, 3, 3, 3. So what is the x1 minus x2? Minus 1, 0,
0,
1,
1,
minus 2, minus 1, 0. Okay, and then minus 3, minus 2, and minus 1. Now, what is the question? What question says? What is the probability that y is greater or equal to 0? So, what is the possible cases y greater than 0? One case,
1 1 1 2 1 2 2.
right? This is the three case, right? So, basically, probability y is greater or equal to 0 means these three cases, right? So, basically, 3 by 9. Yes or no?
Yes, sir.
Understood?
yes,
Why from this 3 by 9 came? Yes or no? So this is the y. Y is greater or equal to 0 in these cases. And why I wrote 3 by 9? Basically, what is the probability here? It will take value 0. It's 1 by
1
3
by
into 1 by
3.
3, 1 by 9. So basically, it's 1 by 9 for all cases. Understood? Yes? No?
Yes, sir. Yes,
Yes,
sir.
sir.
Okay, great. So the next part is, which is related to the previous one, there is another function defined as the z, which is maximum of x1 comma x2. Then what is the value of probability z less or equal to 1? So should I write possible values of x? X is basically uniform 0, 1, and 2, and y is uniform 1, 2, and 3.
So 2 by 9.
2 by 9. Okay, within a second. All right. Two by 9 is for everyone.
2 by
Yes, sir.
9.
2 by 9. Yes.
So what is the maximum of less or equal to 1 actually? So you can think from here, right? Also, so let's say z, I'm writing here. Z is maximum of x1 comma x2. So what is maximum? 0 comma 1? 1.
1,
1,
1, 2, 2, 2, 2,
2,
3, 3,
2,
3.
3, 3, 3. Correct? And maximum is less or equal to 1 only is these two cases,
Two
right?
cases.
First two cases, right? So that is 2 by 9. Understood? Yeah. And I think if there is some function of random variable, you can try it out. Again, function of random variable, same approach you can do. Let me solve something. Again, this is function of random, right? I think
So
this
these
is okay,
questions are
right?
all
This
from week 1 and week 2.
sorry?
So these questions are all from week 1 and week 2.
I think so, but I mean, yeah, it's from week 1 and 2. So yeah, this is from week 1 and 2.
Okay, sir.
So this is one question, whether you have to apply the concept of joint PMF of two discrete random variables. So again, I'm giving you some 3 to 4 minutes. Solve it and let me. Other questions I skipped because those are again related to function of random variable itself. You can try it out. So I will share with PDF with the support team. They will upload under the supplementary content. You can try this later also. Okay.
B, sir.
B. Okay. We will solve and cross check. Is there anybody else who is got B?
B.
B. Okay. Okay. Should I do, or if you are trying, I can wait? Anybody else?
B.
B. Okay. Okay. So let me solve it. Okay. So first of all, to know the value of C and D, right? So we need to know the value of A, right? I can easily find out the value of A. How? Because we know if you see this column, this gives the fx 0, right? And this is the summation of basically what is the case here? A plus 1 by 4 is nothing but 1 by 3. Would you agree with me?
Yes.
Yes.
Right. So from here, what is the value of A? I can get 1 by 3 minus 1 by 4, which is nothing but 1 by 12.
Yes.
So this is 1 by 12. Now, what is the value of C? Basically, what is this 1 by 4? So this 1 by 4 is equal to 1 by 12 plus 1 by 8 plus C. Would you agree with me?
Yes.
So basically, this C equal to, okay, let me write. So basically, what I'm trying to say, 1 by 12 plus 1 by 8 plus C is nothing but 1 by 4. So now, this is, so from here, C will be 1 by 4 minus 1 by 12 minus 1 by 8. So let's take LCM. So it will be 24. 6 minus 2 minus
3.
Sorry, 6 minus 2 minus 3. Yeah, this is 1 by 24. So 1 by 24 is there. Now, how will you get the value of D basically? So basically, 1 by 24 plus D should give me 1 by 6. Correct? So from here, D is 1 by 6 minus 1 by 24, which is 3 by 24, which is nothing but 1 by 8. So option D is correct. Okay. So you can see the concept which we discussed, how it's useful here. All right. So one question, the final question. So just solve this and let me know whether you are getting C as a correct answer or not. Okay. So C is the correct answer, but just solve it and let me know. Then we can wind up.
Isn't this just week 1 to 2?
Yeah, week 1 and 2 only. Yeah, in the beginning also I told you, right? Today we are going to discuss just week 1 and 2 concept and questions related to these 2 weeks which have been already asked in the previous terms. Okay. 3 and 4 session is, you can check the calendar. I'm not sure. I think next Wednesday, if I'm not wrong.
So, actually, I just wanted to ask the mock test. The deadline is today, so it won't be discussed today itself, right?
Sorry, deadline is?
The mock test for
Uh,
week 1 and 2. The deadline is today, right? So
uh,
it won't be discussed today itself.
no, 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 no. That is for your practice. Okay. That is for it.
Yeah, but I have actually doubts from there as well.
Okay, that we can discuss later. Okay, that's not problem.
Solutions of that have been uploaded in on the dashboard.
Okay, okay. They have uploaded, huh? Okay, all right. Yeah. So you can check those solutions. If still you have doubt, you can ask us. That's not a problem. And you can tag to us on Discord also.
Okay,
We are
sir,
there.
thank you.
Yeah.
Yes, sir.
Clear?
C.
See? Should I solve it? Or if you are trying, you want to try on your own, I can wait. That's no problem. So let's, okay, I will wait for 2 more minutes and then. Okay. Should I start? Yeah.
Sir, should this have been y provided y is greater than 0?
No question is correct. I knew this doubt is there. So, okay, just try. Or should I try? Should I start?
Yeah, I mean, if you could just tell me if
No,
how
that
could
is
this?
correct actually. See, what you to observe here, it's asking about single random variable, right? So what you can do, this is the joint PMF is given to you. You can calculate the marginal probabilities for X, marginal PMF of X, and then you have to deal with X.
Okay, but within the same random variable, how do you find this conditional?
Yeah, it's obvious. You can. I will tell you.
You take 0, 1.5 to a 1, na? So it's easy. In numerator, you can take x is equal to 1.
Okay. First of all, okay. Should I solve? Yes.
Okay.
No.
Yeah.
Yes, sir.
So, okay. Okay. Let's say this is A, and this is B. So by using the concept of probability A given B, can I write this X is less 1.5 given that X is greater than 0? Can I write probability 0 less or equal to X less than 1.5 and X is greater than 0 divided by probability X is greater than 0? Yes or no?
Yes.
So far so good. Now what numerator says? Numerator says you have to find the common, right, intersection between this part and this part. So what this part says, more than 0 but less than 1.5, but X take only 0, 1 and 2, not any 1.5, right? So what is the possible cases here? 0 and 1.
0 and 1.
Yes.
What is the possible case here? 1, 1 and
Yes.
2, right?
One and
Now
yes.
just go with greater than 0 part, right? Now what is
Yeah.
the intersection between this circle and this circle?
1.
1.
So this means probability X equal to 1. Numerator part is okay.
Yes.
And denominator part says you have to add probability X is greater than 0, and X takes 0, 1 and 2, right? So this means what? I can add probability X equal to 1 plus probability X equal to 2
Yes.
in the denominator. Now you can see, but in the main question, we have been given the joint. We don't have information about X. What to do? I will calculate the marginal PMF of X. To calculate the marginal PMF of X, okay, what should I do? Tell me. We have to do the summation for the possible values
0.
of Y,
Yes,
for
sir.
all
0
the
to
values of Y. What is the possible values of Y? It's 0 to
2.
2. And what is the joint PMF? 2X plus Y
1 by 27. Yes, sir.
divided by 27. So we have to substitute the value of Y. If you substitute the value of Y 0, it will be 2X. Y substitute 1, it will be 2X plus 1 plus 2X plus 2. Are you getting these steps? Yes, no?
Yes, sir.
Yes, sir. Yes, sir.
This 6X
Yes,
plus
sir.
3, right? Or else I can say 2X plus 1 divided by 9. So I got fx of x as a 2x plus 1 divided by 9. So if you see this, let's say equation number is star. So from star We have to find out probability x equal to 1 divided by probability x equal to 1 plus probability x equal to 2. So if you, what you have to do, we have to substitute the x equal to 1 here. So if you substitute by x equal to 1, what you will get? 3 by 9 divided by here x equal to 1, 3 by 9 plus if you substitute x equal to 2, so this is 5 by 9. So basically 3 by 8. So 3 by 8 should be correct answer. One more approach here you can do, it's asking x is greater than 0. So you can write 1 minus probability x equal to 0. Yes or no? X is less or equal to 0, which is will be probability x equal to 0. Is the idea clear?
Yes, sir.
Okay. So
Yes.
you can try other questions also. I mean, other questions, I mean, again, those are just, function of random variable. Again, just make possible values and find out the, again, this is function of random variable. I skipped these questions, but you can try it also. Other than that, different questions we have solved it. Okay. So I hope you got some idea about week 1 and 2, along with how to solve questions related to week 1 and 2. Okay. Was it okay for everyone? I mean,
Sir,
you were
how
able,
can I get this video access? This
you can find
recording?
it from calendar also. Just check your calendar. YouTube link I have pasted there. This, if you want notes, I will share with the support team. They can upload it later under the supplementary content. Okay. All right. Anything else?
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Great.
Thank
Thank
you,
you.
sir.
Thank you. I hope you got something. You learned something. Okay. Yeah. Bye.
Yes, sir.
Bye. Thank you.
Thank you.
Thank you.